and planners. They ask what must happen first, what can fail quietly, what needs a backup, what should be measured, and how someone will maintain the system after the original design team has gone home. That is where engineering becomes less like a diagram and more like a long-running promise. The risk is that poor drainage can slowly ruin track that looked solid from above. That risk does not make railway engineering fragile, it makes it disciplined. The answer is measured geometry, protected routes, controlled speed, verified signals, planned maintenance, and schedules with room to recover. When those habits line up, railways remind us that smooth motion is built from order. That is why the chapter on ballast and ties matters to the whole story, and why the simplest-looking moments often contain the deepest engineering. Switches. Switches let a fixed path become a network. Switches begins with switches let a fixed path become a network. A railway can look simple from far away, but up close it is a working system of materials, timing, controls, people, and trade-offs. The design has to manage track capacity, energy, time, maintenance access, station space, and public trust at the same time. That is the quiet promise behind this part of railway engineering. Make a complicated system feel ordinary enough that people can depend on it. The working pieces include points, frogs, actuators, heaters, locking systems, detection circuits, and route control. Each part has to match the rest of the system. A strong component in the wrong place can still create trouble, and a small overlooked detail can ripple outward. Good design does not come from one clever part. It comes from the way the parts support each other when conditions change, when demand rises, when a component wears, or when a person has to make a decision quickly. You can see the idea in a train crossing from one track to another through carefully shaped steel. The visible moment may be brief, but it carries the work of track engineers, signal maintainers, dispatchers, drivers, station teams, rolling stock crews, safety inspectors, and planners. They ask what must happen first, what can fail quietly, what needs a backup, what should be measured, and how someone will maintain the system after the original design team has gone home.